Hey, here are the part 2 video solutions to weekly quiz number 7, the one that you guys took last Thursday. Keep in mind there are several versions of this test. So if you received a version where this question was not number 5, just find whichever question number it is on your quiz and review it, okay? It says in the diagram below, triangle ABC is congruent to triangle DEF. There is something that's really important about the way they list ABC and DEF. What's important? Well, A corresponds with D, B corresponds with E, and C corresponds with F. So whatever sequence, and the question asks, which sequence of transformations maps triangle ABC onto triangle DEF. Whatever sequence of transformations is the correct one, and in this case it's B, should map these two triangles and their vertices or their points directly onto each other. So I tried A first. So I did it here. I reflected it over the x-axis and then indicated that if a translation was done, it would probably be in this direction. And if we do reflect this over the y-axis, the x-axis, this is how the triangle looks. And obviously, if you slide it over to attempt to superimpose it or map it to DEF, it would not work. Okay, so that's why this answer is not correct. But then I tried the second, and so I reflected it over the y-axis as it says, and followed by a translation. If we translated this downward, our A would map to D. So those vertices would be, right, those corresponding vertices would map to each other. B would map to E, right? We brought this down. B would end up here, right over E. It would map directly onto it. And C would map directly to F. So if I brought this down, it would end up, this vertex would end up, or this vertex rather, would end up at F, okay? So that's why B is your answer, because the corresponding vertices, or we could even call them angles, would map to their corresponding vertex or angle, okay? So it's none of the others. It is definitely B. A lot of people got that right. On to the next question, which luckily a lot of people got this correct. Not everybody, but a lot of folks got this correct. So it says when two parallel lines are cut by a transversal, which angles are not always congruent? So the first choice is A, a pair of alternate interior angles, B, a pair of alternate exterior angles, C, two interior angles on the same side of the transversal, also known as same side interiors, or D, two corresponding angles. In this case, the answer is C. But why is that? So I came up with this color coding system to help assist you with that theory. So the idea of two parallel lines cut by a transversal and the angle relationships that are created is based on what we already know about vertical angles and linear pairs. For instance, these two lines intersect to create these sets of vertical angles and these linear pairs. If you take a look at this angle here and this angle here, which are considered alternate interior angles, they are both purple. They're congruent. They're the same color. Same thing here. These alternate interior angles, they're both pink. They're congruent. Same side interiors, notice they're different colors. They are supplementary. So wherever you have, and same thing with the corresponding angles, right? So we have a corresponding angle, that set of corresponding angles here. They're the same color. They're congruent. Set of corresponding angles here, same color. They're congruent, okay? So the only situation where you have supplementary angles is when they're same side interiors, okay? So if your same side interior angles are supplementary, they equal 180, that means that you have a set of parallel lines cut by a transversal. Essentially, these two being supplementary will prove that these two lines are parallel. Your alternate interior angles will prove that as well. Your alternate exterior angles will prove that as well. And your corresponding angles will prove that as well. On to number 7. Number 7, as shown in the diagram below of triangle ACD, B is point on a segment AC and DB is drawn. Okay, I read that all wrong. As shown in the diagram of triangle ACD below, B is a point on segment AC and DC is drawn. That language is not the best. All right, sorry about that. It says here if we're given that angle A is 66, CDB is 18, and angle C is 24, what is the longest side of triangle ABD? A lot of people got this incorrect. Not sure why. If you notice here, we have two triangles, right? We got two of them. So we got this one right here, this triangle here, and then we have this one right here. So what's missing? What do we not know? Well, we don't know the measure of this angle, or this angle. But I'm given the measure of angle angle CDB and angle C. And because I know that, all I have to do is, I'm trying to find a calculator, but maybe I'll do it without one. Let's see, the calculator here. All right. So using triangle sum theorem, I'm just going to figure out what is the measure of this missing angle here. So 18 plus 24 gives me 42, and so I take 180 minus 42, and that gives me 138. We have a linear pair, right? Two angles adjacent to each other, meaning they share a side, on the same line. Linear pair is literally two angles that share one common side that are on a straight line. So they are supplementary to each other. So I take 180, subtract it from 138, and I get the measure of this angle, which is 42. Okay, so now I need to know what the measure of this angle is. Why? Because I know that if I'm trying to find the longest side, it is literally directly opposite, right? If I'm trying to find the longest side in this triangle here, it's going to be directly opposite the largest angle. Longest side, opposite largest angle. Okay, so I have a 66-degree angle, a 42-degree angle. I just need to figure out what this is, all right? So 66 plus 42 is 108. So 180 minus 108 is 72. I have a 72-degree angle here, and that's the largest angle. And the side that's opposite is side AB, making that my answer choice. Okay, last one of part of this video. If the measures in degrees of the three angles of a triangle are x plus 10, and 2x minus 6, the triangle must be what? I like to draw an image. In this case, because I know triangle sum theorem, I'm just going to come up with an equation. Three sides, one side, two sides, three sides. 4x plus 4 equals 180. Subtract 4 from both sides. 176. And that gives me x is 44. So that means one angle is 44. The other is... One angle is 44, the other is 54, the other is 2 times 44 is 88, minus 6 is 88 minus 6 is 82, if I'm not mistaken. Right? So this is definitely a scalene triangle because it has 3 different angle measures. Okay, let me show you the rest of that I did here. You're missing some of that. Sorry about that. Okay, so a scalene triangle is a triangle with 3 different angle measures. Equilateral, all angles are the same measure. Isosceles, 2 angles are the same measure. And a right angle is just simply a triangle with 190-degree angle. Okay, so I know it's kind of difficult to see. The sun is coming out, and so it's a little bright in here, and the brightness is affecting what you're seeing. So this says equilateral, all angles are the same measure. Scalene, 3 different angle measures. Isosceles, 2 angles are the same measure, and a right triangle has 190-degree angle. All this stuff you should know. Part 3 with the rest of the solutions as well as part 4 will also be posted shortly.